Okay, so in our previous video, we found that when we equated gradients of these two functions, we ended up with k equaling 1 or -4. So now in the sequel to the previous video, what we're going to do, we're going to see what happens if we let k equal 1 or k equal -4, and from there we're going to determine numbers of solutions to these two equations. So first thing, we're going to substitute k equals 1 into both of these. So if we let k equal 1, we end up with equation 1, we'll call that, and equation 2. Equation 1 becomes y equals 1 plus 2x, and equation 2 becomes y equals 1 plus 4 over 2x, which then becomes 1 plus 2x. So now, if k equals 1, we end up with the same equation. Therefore, we have an infinite number of solutions when k equals 1. Now, we're going to try to see what happens when k equals -4. So we're going to substitute. So we're going to rewrite this over here. So we've got equation number 1. Substitute k equals 4. We end up with y equals 1 plus 2 over, and it's -4, x. So that is 1 minus 1 over 2 x. Use equation number 2. Y equals -4, and then we'll have plus -4 plus 3 is -1 over 2x, so we end up with -4 minus 1 over 2x. So what do we see happening here? Well, we've got the same gradient, -1/2. We've got a different y-intercept. So over here we have no solutions. So now, when k equals 1, we have an infinite number of solutions. When k equals -4, we have no solutions. Therefore, for one solution, k can be any number, or k is an element of any real number apart from, it's a bit hard to draw that curly bracket, 1, write it as -4, and 1. So, there is a way we can do it using matrices, but you don't get an idea of what's going on, I don't think. So I'm not going to go through that. This makes sense. Equate them, take your equations and write them in y equals mx plus c. Once you've done that, find your two gradients. One gradient here, the other gradient here. Whatever's your coefficient of x is your gradient. Let them equal each other. And then you'll find that k will equal 2 possible values. Or 1, I don't know. But anyhow, you'll find that k equals something. Check what k equals when you substitute it into your equations, because then something will happen. So over here, like we found here, same y-intercept, same gradient, infinite number of solutions. K equals -4, same gradient. So same gradient, different y-intercept, no solutions. And therefore, if if k is anything apart from -4 or 1, then we have one solution. I better write that down. So that's what we need to do.